Hi Charlotte, I'm going to assume that you're busy today and not able to attend class, so I'm just going to go ahead and go over the things that I would have done if you were here. So we're talking today, working on this unit on money and how we can apply our knowledge of decimals to money. So if we were to do this, pretending that there was a vending machine that takes only dimes and cents. So cents would be like 1 cent, right? We obviously don't use that in Canadian currency anymore. We don't have pennies anymore. But if we did, what would you use to buy a toy that costs 46 cents? So we know that we would have 4 dimes, right? So 1, 2, 3, 4 dimes. And they would all be worth 10 cents, right? And we would need 6 pennies. 1, 2, 3, 4, 5, 6. And I drew them like this. In our actual money, pennies were bigger than dimes, but I drew them like this to show that dimes are worth more than pennies. So we got 1, 2, 3, 4, 5, 6 worth 1 cent. So counting by 10, 20, 30, 40, and then 41, 42, 43, 44, 45, 46. So that would equal 46 cents. Okay, so notice here you really need to know how much dimes are worth and how much pennies are worth. They say cents, should have said pennies, but that's all right. So dimes are worth 10 cents, right? Now, if we wanted to write something like 26 cents in dollar notation, right here it's in cent notation. We call it that because it uses the cents sign. If we wanted to write it in dollar notation, we have to start with the dollar sign at the front. Different than the cent notation because cents go at the back when we use that. And if it's 26 cents, we know that we have $0, right? We always have to use the 0 and then the decimal and then put in our 26 over here to show it's 26 cents. Remember that 100 cents equals $1. So notice that we move the decimal place over 2 spaces right to here when we change it to the dollar notation. Here they're asking us to write the amount in dollar notation. If we have 0 dimes and 6 cents, dollar notation, so we'll start with the dollar sign. We have $0, 0 dimes, and just 6 cents would be like this. If we have 3 cents, very similar, dollar sign at the very beginning. Sometimes you'll see the dollar sign with just one line through it. You can do it 1 line or 2 lines. It really doesn't matter. Either way works. $0, 0 dimes, 3 cents. 7 cents, very similar, $0, 0 dimes, and 7 cents. Now this one we have 5 dimes and 0 cents, but we're still doing dollar notation, so we still start with the dollar. $0, 5 dimes would be 50 cents, right? 0 cents, like that. Now down here we have 40 cents, so we're going to write our dollar sign, $0, and 40 cents. And for 92 cents, again, start with the dollar sign, 0 whole dollars, and 92 cents. Okay, not too tricky, but just something to be aware of so that you understand how to use the cent notation and dollar notation. Now, just like I said, if we're writing these in dollar notation, 100 cents equals $1. So 200 cents would be $2. And notice here we're not putting the decimal 00 at the end. You can to show that there's no cents left over, but again, you don't have to. Okay, it's just like if you write 1 or you write 1.0, it's the same amount, right? You can write as many zeros as you want after that decimal, and it doesn't change the amount. It's still just 1, right? So it's the same thing with money. Here we've got 1,300 cents. We're just going to do the same thing. Back up the decimal 2 spaces, right to there. So we end up with $13. Speaking of 13, on to slide 13. If we're going to change the dollar notation to cent notation, now we're going the other way. $13.85. We just write it out like this. $13.85. How many cents are there in $13? Well, we know that there's 1,300, right? We just did that. Plus 85 cents would be 1,385 cents. So again, we would just take that decimal and move it the other direction if we're going from dollar notation to cent notation. So it's pretty simple here. Write the dollar amounts in cent notation. Again, move that decimal 2 spaces over. So we're going to end up with 800 cents. For B, 1,700 cents. For C, we've got $0, so it's only 28 cents. And in D, we have 4 cents. E, we have 354 cents. And now be careful because now we have 903 cents, right? You can't miss that 0 in between when we have something in the dollars space, okay? Here, because we had $0, we didn't need to put the 0 in front. That would look silly to put 028, right? But because we have something in the dollars space here, we have to make sure that we put that in our answer as well, okay? For the bonus, let me see if I can move it up a little bit here. $999.99. Again, we just move the decimal 2 spaces over to say we have 99,999 cents. Okay, not really too tricky as long as you remember which way you're moving the decimal. Now they're asking us here which one is more money, 80 cents or 205 cents. Well, it's pretty simple to see 200 is more than 80, right? So 200 is definitely the bigger amount. Here we have 3,579 cents or 543 cents. Obviously 3,000 is bigger. Watch your place value and you've got it. 344 cents or 7,102 cents. Again, just a matter of watching your place value on those, okay? Sometimes they will give you a cent amount in cents notation and in dollar notation, and then it might be a little bit trickier, but just think about what they're asking and you'll get it. Like in this one, which one is greater? 234 cents and $2.15. Well, if you know that there's 200 pennies or 200 cents in $2, then you know that this is going to be, in dollar notation, $2.34. And then you just compare the numbers, right? Just like you would if they were whole numbers. $2 and $2 is the same. 30 cents and 15 cents, there's our difference, right? So we know that this one is the bigger number. So it gets fairly easy to tell as long as you know how to change from the cent notation to the dollar notation. Looking at this one, now they want us to write the amount in words. So remember, even though the dollar sign comes before in the dollar notation, when we write it in words, the dollar sign we say after. So we write it the same way that we would say it. We would call this 17, oops, messed the end there, dollars. And remember the decimal sign means and. 4 cents. So notice when we use the words, then we would use the dollars and cents in our answer if we have dollars and cents. If they just said this $17, obviously we wouldn't say and 0 cents. Or if it was just 0.04 dollars, then we would just say 4 cents, and we wouldn't say $0.04. Not usually anyway. Special occasions you might, but not generally. Now we're going the other way, changing money amounts into dollar notation from the words. So obviously dollar notations start by writing the dollar sign. If you do not write the dollar sign, you will have marks taken off. So make sure you always write the dollar sign. So here we have $4 and, there's that and word, 40 cents. Again, we're doing dollars notation, so before you even read the question, you know dollar notation, so write down your dollar sign so you don't forget. $18 and 5 cents. Be careful that you don't write just 18.5, because whenever we use dollar notation, we need to have the 2 decimal places, right? If you write 18.5, that will be wrong as well, because that will imply that you just forgot to put the 0 there to make it 50 cents. And that's not what we have here. It's 5 cents. So make sure you put the 0 in the tenths place and the 5 in the hundredths place. C again, dollar notation, $73.84. And for D, we have $50.60. Last one on this slide deck, how much money is in each stack? This one gets a little bit trickier because you need to know how much each of these are worth. Pennies are worth how much? They're 1 cent. Nickels are 5 cents. Dimes we already talked about in this lesson. Dimes are 10 cents. And quarters are 25 cents. Loonies are $1. And $5 bills will be each worth $5. All right, so if we take 19 pennies, I'm going to change colors here to make it clear what I'm doing. Let's change to a light blue. 19 pennies will obviously be 19 cents because each one is worth a penny, worth 1 cent. If we have 8 nickels that are each worth 5 cents, it's like saying we have 8 groups of things that are 5 cents. And so 8 times 5, we could multiply them to get 40 cents. 21 dimes, same thing. 21 groups of things that are 10 cents. So 21 times 10 will be 210 cents. Or, because it didn't say which notation to use, cents or dollars, we could say in dollar notation $2.10. Either one works. If it's said in dollar notation, then I would expect dollar notation. But if it didn't say, then either cent notation or dollar notation works. Here we've got 5 quarters, and each quarter is worth 25 cents. So 5 times 25, you could work it out here. 25 times 5. 5 times 5 is 25. 5 times 2 is 10, plus 2 more is 12. So 125 cents. Or again, we could say in dollar notation, $1.25. 6 loonies. We know a loonie is $1. So we're just going to skip up to dollar notation and say it's 6. 6 times 1 will be 6. And again here, because we have $5 bills, it's in dollar notation already. So 3 times 5, 15. Okay. So there's a basic dollar and cent notation, how to write them, how to convert them from dollars to cents, cents to dollars, and also using the words. Now adding money. This is not going to be difficult because you've already added decimal numbers, and adding money is the same thing. So the only difference between adding other addition, like whole number addition, is lining up the decimal point, which we already talked about, I think, in our last unit, right? So they've lined up the decimal point for us. So 3 plus 4 is 7. 3 plus 7 is 10. So we leave the 0 digit down there, put the 1's digit up here to carry it over. 2 plus 2 is 4, plus 1 more is 5. So our answer is $5.07. Remember, and is the decimal place, right? Pretty simple how to use that. You will see now they will put all this information together into problems that are supposed to be like everyday sort of things. So here's one example. Sharon saved 5 loonies, 5 dimes, and 3 nickels from babysitting. I'm going to change colors because we've got a different person now. It says her brother Ronan saved a $5 bill, a loonie, and 3/4 from shoveling snow. Who has saved more money? Well, because I've got this light blue already on my pen, let's add these up first. So we've got a $5 bill. That'll be $5 like that. A loonie we know is $1. And 3/4, each quarter is 25 cents, so that will be 3 times 25 cents, right? And remember we worked on this before. If we multiply 25 times 3, count by 25s. 25, 50, 75 cents. So adding that all together, her brother had a total of $6, 5 plus 1 is 6, and 75 cents. So there's how much Ronan had. Let's look how much Sharon had. We'll switch back to Sharon's color here. Sharon saved 5 loonies. Each loonie is $1, so 5 of them would be $5. 5 dimes. Each dime is 10 cents, so 5 dimes would be 50 cents. And 3 nickels. Nickels are 5 cents, so 3 times 5 equals 15 cents. Adding that up, 5 plus 50 plus 15 I'm putting it this way because our decimal point is right there, right? And I could add the zeros in, but I don't have to. So 0 plus 5 is 5, 5 plus 1 is 6, and 5 plus nothing is 5. So that's how much Sharon has saved. So who has saved more money? Which one is more? Oops, this dollar sign didn't work too well. $5.65 is less than $6.75, so Ronan saved more. They want to share their money to buy a present for their mother. How much money do they have all together? If we want to know all together, we want to add them together. Both of them are added together, right? That's what all together means. So 5 and 65 cents. 6 and 75 cents. Adding them, what do we get? 5 plus 5 is 0. 6 plus 7 is 13. Make sure we put that decimal down there. Sometimes people do it before they even start adding, just so you don't forget it. That's not a bad idea. 6 plus 5 is 11, plus 1 more is 12. So altogether they would have $12.30. Now in this one, I'm not sure why they're just having you subtract. I guess just reviewing 2- and 3-digit subtraction questions. When you get questions like this, some people try to puzzle it through subtracting sideways. I would never suggest that you do that unless you find it really easy to subtract. If you have any trouble with it at all, I would always write it out like this, 45 minus 23. Write it vertically instead of horizontally. This is vertically instead of horizontally, just to make it easier on you, because then you can easily see, whoops, I did a 5 there instead of a 3. 5 minus 3 is 2, 4 minus 2 is 2. Right? And I'm not going to go through them all just because that's all I wanted to show you, is just how to subtract them vertically, change it to vertical instead of working on horizontal. Here's another problem, a very typical problem that you'll find here. Amir went to a grocery store with $15. He would like to buy buns for $1.45, ice cream for $6.50, and tomatoes for $2.50. Does he have enough money? There's the question that we want to answer first. And if yes, how much change will he get? So we know that change is the amount of money that you get back when you buy something, right? And the way it's calculated is they take the money that you give to them and subtract everything that you have bought and then give you back the money that's left over. So really when they ask how much change will he get, they're asking how much money is left over at the end. Well, first we need to know how much money he's going to spend, right? That's our first step. So first step is to add up $1.45. And when you're doing this work, you can put the dollar sign in. It doesn't really matter if you do, as long as you remember to put it in at the end. $6.50 and $2.50. Adding them all together, sometimes we just put a dollar sign on the first one, and then we know all the rest of it. Because if the first one is money, it's all going to be money. You wouldn't add money and kilometers. That doesn't make sense. So if there's a dollar sign on the first one, it means all of them are dollar signs. And you can put the dollar sign on the bottom, put your decimal place in there so you don't forget it, and then do your adding. 5 plus 0 plus 0 is 5. 4 plus 5 plus 5 is 14. And 1 plus 6 plus 2 plus that other one is 10. So $10.45. Are we done the question? No, because this is only the amount that he is spending. This doesn't tell us if he has enough money or the change that he'll get. So first, or the next step, this was the first step, to add it up. Second step is to compare. And we're going to compare $15 and $10.45. He has $15. He wants to spend $10.45. Does he have enough money? Yes, because he has more money than what he wants to spend. So our answer for this one is yes. And so they go on to say, if yes, how much change will he get? Remember that change is the amount that's left over after he has spent his money. So our third step is to subtract. We have to take the amount that he walked into the store with, $15. Make sure your decimal point is nice and big so it's visible. Subtract the $10.45 to find how much change he will get. And we have to borrow for this. But we can do that, right? Borrow from there, move it over to here. Oh, we still need to borrow again, so leave 9 there, and this becomes 10. Because if we switch 1 dime for 10 pennies, Then we leave 9 dimes there, and we have 10 pennies here to now subtract 5 pennies from. So we've got 5, 9 minus 4 is 5. Put a decimal in there. 4 minus 0 is 4, and 1 minus 1 is nothing, so we can leave that blank. So how much change will he get? He will get $4.55. So be careful when you come across problems like this that you do every step. And if you're not sure if you've done every step, go back and read the question again. It's not a bad idea to draw a little star beside each of the questions so that you know that you have to do more than one thing. And that will help to keep you on track, make sure that you get all of the parts done. Sometimes too here you'll have to find the difference owed. So the price, for example, $5.65, and the bill used, $10. Same thing as finding change, right? So you start with the $10 and subtract $5.65. And again, we have to borrow for this one. Often happens, right? 9, 9, and 10. 10 minus 5 is 5, 9 minus 6 is 5, and 9 minus 5 is 4. So $4.55 is our answer for this one. They will show you a different way. I can't remember if this is in the book or not, but somewhere here they showed you an easier way to subtract from 99 cents rather than $1. But I think that that's more confusing at this point. So since you know how to borrow, then just go with the borrowing and do it that way. And that will make as much sense as anything. Our last part of this lesson here is on rounding. So here it asks you to draw an arrow to the closest whole number. For this one, from 1.4, our closest whole number will be 1. From 1.8 or 1 8/10, our closest whole number, remember, will be 2, right? Because remember, this is our deciding number, right? 1.5, if it's 5 or more, it goes up. But if it's less than 5, it goes down. So 2 6/10 goes up to 3, and 2 7/10 also goes up to 3. Sometimes we'll think of a number in terms of the closest whole number because we don't want to or need to be precise, and whole numbers are easier to work with. And so it's just rounding, just like you did if you had the number 15 and you wanted to round it to the nearest 10. If it would be 10 or 20, we know it would round up to 10. Rounding works exactly the same with decimal numbers. It's just that there's a little decimal there in between. That's all. That's the only difference there is. So here we have a chart, and we want to sort if they're closer to $3, I say $3 because it looks like dollar notation, right? Closer to 3 or closer to 4? Well, we just want to look at the number that is next to the 3, right? So if we look at this number here, 3 56/100. This one, we know we round up if we have a 5, so it's closer to 4. 3 42/100 is closer to 3. 3 12/100 is also closer to 3. 3 85/100 is closer to 4. 3 52/100, remember 5 means that it goes up, so closer to 4. 3 31/100 is closer to 3. 3 27/100 is also closer to 3. 3 90/100 is closer to 4. And 3 9/100 is closer to 3. 3 51/100 is still more than 5, 5 or more, closer to 4. So that's where all of those go. Now that's rounding to a whole number. Sometimes we want to round to the nearest tenth. Same rules apply. We don't look at the 2 because it's going to stay the same. We look at what's in the tenths place, and then we consider the digit that's next to it. So if the 6 is higher than 5, we know that the 3 has to go up. So we're going to change it to 2 4/10. And because it says to round to the nearest tenth, we're going to leave this space, the hundredth space, blank. Nothing in there because we only want to the tenth. This is something that's really important as you get into higher math and science. When you get into high school science, they're going to assume that you know how to round numbers, and you're going to be asked to round to a significant digit, is what we call this. The tenth is the significant digit. And they're going to ask you to round to this digit. If you put a 0 into the hundredths place, then some teachers will actually mark it wrong. So make sure that you understand when you're rounding to the nearest tenth that you put nothing else after that. That's different than when we're rounding to, for example, the nearest 10. If this number was 236, and we said round to the nearest tens, then we would round to 240, and we need to put that 0 there to show that it's 40 and not just 24, right? So like the hint says down there, if the digit next to the underlined digit is more than 5, round up. If it's less than 5, round down. It's the same rule, doesn't change. And these are just some examples. Round to the underlined place value. So here we look at, we have a 5. So that means that the 4 goes up. So we have 13 5/10. Here we're rounding to the nearest 1. So we look at the digit exactly to the right. It's a 4, so that means that we keep it the same. So it's 38. 612 3/800. We look at the digit to the right of the underlined number, which means that we want to do something with the tenths. So 612 doesn't change, the tenths go up. And in D, 804 7/400, look at the digit to the right of the underlined one. We end up with 804 7/10. And just to end off here, just thinking about what place value does it make sense to round to, and justify your decision. So if they ask you questions like this, there's not really a right or wrong answer, because it really depends on the situation. If you're calculating the height of a person and you need it to be exactly precise, then you might want to go to the thousandth place. But generally, when we're talking about how tall someone is, we don't go further than the tenths place. So this one we would round to 1 5/10 of a meter, or 1 1/2 meters is what we would normally say. Again, the height of a tree, generally we don't need it to be this precise. If it's 13 meters or over 13 meters, usually 13 meters is just good. But I wouldn't mark it wrong if you said that this was 13 1/10 meters. That doesn't really matter. The length of a bug, well, if you're trying to scientifically determine if this bug is a tiny bit bigger than another bug, then you might need it to the hundredth place again. Generally, we would only do it, I would see, to the hundredth place, though, not the thousandth place. So I would round this to 1 27 centimeters, 27 hundredths of a centimeter. The distance between Quebec City and Hong Kong, we probably don't need to know that it's closer than 12,300 kilometers. So we'd probably round it to the nearest 100. And the distance today between the Earth and the Moon, it changes every so often. So we're not sure exactly, I don't know if this is exactly how far it is today or not. But I would say we probably don't need to know more than 384,000 kilometers. Because I can't even imagine that distance, let alone any more. All right. So there you go. There's our lesson for this week. Work through the work. Let me know if you have any questions or if you have any problems with them, and I can help you out with it. I hope you enjoy working with the numbers. Whoops, sorry. I hope you enjoy working with the numbers because I find this to be a pretty easy unit. But yeah, like I said, if you have trouble, just let me know and I'll help you out.